In this video, I'm going to go over why tan of theta is the same thing as the sine over the cosine of theta. So if we have a right angle triangle like this, and we label each of the sides as opposite, hypotenuse, and adjacent. So we have this here is a right angle here, and we're going to label this angle as theta for simplicity. This side, the opposite, will be labeled as the opposite side. And this side that's right next to it, over here, will be labeled as the adjacent side. And the longest side to a triangle is always called the hypotenuse. So opposite, adjacent, and hypotenuse. So whenever we do a proof, or whenever we try to show something, we must always start with either the left-hand side or the right-hand side to prove our statement. So I'm going to start with the right-hand side of my equation, the right-hand side, which says that sine of theta over cosine of theta. So I need to try and somehow manipulate this and turn it into tan theta. So how can I do that? Well, another way of writing the sine of theta is simply the opposite divided by the hypotenuse. So I'm going to write that on the numerator, the opposite divided by the hypotenuse. And another way of writing the cosine of theta, which is here, is simply the adjacent side divided by the hypotenuse. And for those of you wondering how I got that, it's so, ka, and toa. So sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. So I'm going to say we can do divided by the cosine of theta, which is adjacent, divided by hypotenuse. So now that we have this, we need to somehow simplify this fraction. And whenever we divide two fractions, it's the same as timesing by the reciprocal of the second fraction. So opposite over hypotenuse times by hypotenuse over adjacent. And the way I got this is keep, change, flip. Keep the first fraction, change the sign from divide to times, and flip the second fraction. So I'm just going to flip it from adjacent over hypotenuse to hypotenuse over adjacent. And now that I have this, you'll notice that hypotenuse divided by hypotenuse cancel each other out. So these two will cancel. And all you're left with is the opposite divided by the adjacent. And we all know from right angle trigonometry, opposite over adjacent is the same thing as the tan of theta. So that's why whenever we do the sine of theta over the cosine of theta, that equals to the tangent of theta.